welcome to participate INBAR 2022. Where does this started or this session? In order to implement Xi Jinping, the General Secretary's and spirits of the developing the bamboo industry in accordance with the local conditions during his visit in Sichuan and other bamboo growing areas, for this session will be held with the theme the innovative development of and bamboo forest economy and healthcare industry with bamboo. We invited the relevant experts. First of all, I would like to invite Director of Academic Department of Chinese Society of Forestry, Secretary General of the Story Economy Branch of the Chinese Society of Forestry, Professor Zheng Xiangwei. Thanks, distinguished guests, dear experts, delegates. Good morning. And during the countryside to learn the 20th the Congress meeting, and for we talk about this and forest the economies, and for this session is held by the Chinese the Society of Forestry, and also get the supporting from the INBAR, and also for the Nanjing and Southwest Forest Universities and Zhejiang NF Universities, and also on behalf of Chen Xinliang, Professor, and I would like to give my congratulations for this meeting, and to extend our warmly welcome and gratitude to all the participants. And for this session, at the theme of bamboo and forest economy and forest recreation industry development, and we would like to take these opportunities to promote our communication with the industry and to explore a route for the Chinese the and forest economy development. Bamboo and forest economies is with a very unique resources and characteristic, and to build and give the full play and on this promote the economy and to bring the welfare for the people. And China have over 4.7 million hectares for the bamboo forest, and for those 8 million populations on working on this industry. So that is bring a new mode for our development in future. So how to promote for this forestry recreation industry, and to persist for this lucid waters and large mountains are invaluable assets. This indication, and to build this beautiful rural and bamboo forest this results. And we would like to take this opportunity to provide some support for this industry. For this theme of the sessions is the bamboo and forest economy and forest recreation industry development forum. We want to find the reference for the successful stories and cases, and to promote the and forest economy development. For China Society of Forestry, and with a 100 development and founded in 1997. And that is a very long, very completed society in China with a very good, prestigious awareness inside and outside China. And we have the completed organizations and branches, and with over 200 and group the memberships. And June to 2022, Sensor Technologies and the groups, we are ranked the top 30 for globals the in this regarding. So China's Society of Forestry will take the present sheets and the guidance as our the mission, and will leading the academia area society going forward and to promote the forestry and grass in the industry and going forward. I wish a fully success for this session and wish a good health and good work. Thank you. Thanks to Director Zheng's the opening speech, and Director Zheng gave us this the views on the society from the Society of Forest. So we will based on this and to have a further discussion. Again, thanks Mr. Zheng. So we have 5 experts presentation in this session. The first presenter is Dr. Cai Chunju from the ICBR. Is worked on for this the bamboo and rattans and the resources development, and also the technology improvement, and also holding and 13.5 years and the projects, and over 20 projects, and achieved 9 awards, and also to release the 2 standardizations and give the over 60 papers and achieved the awards. And in the meantime, Professor Cai is also the members of all those and the 30 the urban the forest, and also for the bamboo forests the commissions. Professor Cai's the theme in this session is the exploration and the efficient cultivation of medicine resources in bamboo forest. Welcome. Thanks, Dr. Chen, for your introduction. Well, today my presentation is on research on the bamboo medical species compound management technology and our progress on this research. Because that is one of mode of versus under forced the economy. So my main content on this the presentation is for the first of all is a non-timber forest-based economy and main models, and some models for the under the forest economy is kind of the eco-friendly economies relying on the forest, woodland, and the economic ecological environment, and that the related the areas. So for oil and forest economies, together with the China's Institute of the Forest and Grass, and we have the standardization for the terminology for this the area. It's like a non-timber forest-based economy. We can see for this non-timber forest-based economy, which is carried by woodlands or relying on a forest ecological environment, and with this like the underwood or above, is a very economic friendly development mode, and with a good ecology, both business objectives and economic security. It's also gave a play on the to practicing the lucid waters and large mountains are invaluable assets. This the inductions. So we have the four kind, like planting, breeding, and also breeding, and also for the forest landscape utilizations. There's four kind. There's the products. It's like a forest plus N, this kind of mode, and to develop this. Currently, we're already over the 100 kind of the development in this regarding. And this is actually is with the very important, the treasure house for Chinese herb medicine. We have over 11,000 kind of the Chinese medicine herb, and we also have the over 323 million hectares for the forests, the areas. We can achieve all these herbs by natural means. We have the for planting, breeding, and also animal and mineral, fungus, this different kind of the herbs. So the process to build this forest medicine mode is a process to achieve the all. And I'm talking about this impact of bamboo forest management on biodiversity, and that based on this, based on the bamboo forest resources and distribution, and also including the based on this, for the bamboo forest is an important integral part of the forest ecosystem. We have 123 genera and 1,642 species of the bamboo forest worldwide. We have the 39 genre and 647 species bamboos in China, which rank #1 in the whole world. In my areas in Sichuan, for this the Shunan, Sichuan, southern areas, which will have rich biodiversity and with the huge territorials of the forest kind. And we also the wild giant, the pandas, the habitation area.
And different species are living in bamboo forests. So there are 86 families, 166 genera, and 231 species of plants, including 13 families, 21 genera, and 30 species of ferns, families, etc. And also there are some very valuable fungi for food and medicinal purposes. So actually, the resources in the bamboo forests with our development and the impact of the management measures on bamboo forest biodiversity is continuously improved because of our progresses in technology, and we tend to be more precise and efficient, and increasingly improved bamboo forest management technology system has come into being, and the targeted management and the efficient cultivation, the healthy management and ecological management. And in all these aspects, we have developed our systems, and the main economic bamboo species cultivation technology became mature with a high management level. The output of single products can be greatly improved as well, and also as the management is intensified, actually the mixed bamboo forest tend to be converted into the pure bamboo forest, and the stability is improved, and the hardwood and bamboo mixed forest accommodate 85 families, 139 genera, and 165 species, which demonstrate the very good biodiversity. So in the intensively managed mossel bamboo forest, so actually the biodiversity is significantly reduced, and only 44 families, 72 genera, and 81 species are in the pure mossel bamboo forest. And this is the ecological station in the charge of me in Sichuan, and the intensively managed pure bamboo forest will result in the soil degradation, productivity loss, biodiversity reduction, and pesticide threatening. So, and also the investment in terms of labor and products will result in the high price of bamboo raw materials. In our research, we also consider the ecological function and the bamboo forest productivity. We need to maintain the biodiversity and the productivity at the same time. So by different methods, for example, the leveling of hilltops, no tillage, implanting broad-leaved trees, and retaining undergrowth vegetation, we could improve the forest management. And also, we proposed the solutions to optimize the structure and protection of the understory vegetation in order to conserve the long-term productivity and the biodiversity. So all these measures could benefit the highly valued understory plants and species. And next, I'm going to introduce our progresses in the comprehensive management. And the bamboo medicine compound management is a non-timber forest-based economy model. And undergrowth plants and planting methods should be determined according to the ecological characteristics. And we selected the optimal plant species according to the geographical location, the ecological property, and the adaptability of the medicinal plants. And on the basis of the bamboo forest management, and we will intercrop the medical species, considering the bamboo density and age structure. And we need to consider both the productivity, but also the growth characteristics of the plants. And finally, we selected the medicinal plants, including the polygonatum, the tetrastigma, and also the Laphaserum gracile, etc. In the interest of time, I would not elaborate on every details. I would introduce several technologies in the management model. And the first one is the muscle bamboo polygonatum Ceatonia the cultivation method. And the polygonatum can grow naturally in the bamboo forest. We provided the main technical points. And first, we need to select the say shady or semi-shady slope of 15 to 25 degree flatland near water resource, and also the age structure, and should be like 1 degree, 2 degree, and 3 degree age structure should be 4 to 3, and also the density should be 160 to 200 per mu. So in the planting technology, we need to select the seedling, and also choose the late October or the last 10 days of March as the planting time. And the method is to cover a thin layer of soil for the underground tubers. And also, we need to control the living bamboos in order to meet the requirements for living bamboo density, and also the moisture and the irrigation need to be managed properly. And also, we need to remove the flower and top it. And in April, June, July, May, September, and October, we adopted different methods to remove the flower and top them. And also, we calculated the economic output. After 3 years, the yield can reach 100 to 120 kilogram per mu without influencing the bamboo timber and bamboo shoot production. We could realize 2,000 to 2,500 RMB per mu. So the economic benefit is good. And second model is the muscle bamboo tetrastigma Hamsleyan. And this is a plant of Vitaceae family. This is a very good material used for medicine, and it is an antibiotics. And also, it is antibacterial and anti-inflammatory. It is a very good antibiotic. And also, in the production, we need to select the acid soil. Usually, a shady sloping field is preferred. And gradient should be less than 30%. In the land management, we could treat it as a flat land. And also the planting technology is not so complicated. And we need to choose the 1-year-old cutting seedlings and plant 3,000 seedlings per mow and 2 seedlings in each bag. And we also can use some bags in order to prevent water from accumulating, and some cares and management are needed. And for example, we need to remove the tops of plants in April, and in order to well manage the shading degree. And usually the economic output of this model will be generated after 3 years, and the income could reach over 3,000 per mow. And the third model is a muscle bamboo oil featherum gracile, and this is a kind of perennial plant, and the density should be 170 to 200 per mow, and the canopy density is 3% also, and the economic output can reach RMB 2,000 per mow. As for the other models, I would not elaborate on it, and I would like to exchange our experiences with you after the meeting. And there are muscle bamboo and some medicine, or say medicinal herbs management models, and fungi, everything. And also, I would like to provide some suggestions on the development of bamboo medicine compound management. Actually, in our interaction with the farmers, we have summed up the following experiences from the perspective of industry and research and researchers. First, we need to focus on the market demand, and the medicine market is fluctuating all the time. So we need to know which varieties are suitable for the market, and also we need to know and what technology is mature enough, and also we need to know which species are preferred by the market.
To choose those the local, the origins species, and nearly natural, and which being recognized by the regulations. Second, we need to carry out the in-depth development, use the products for medicine and food, and produce the more products. For example, like the polygonatotum, this can be used for tea, for cooking, and also to sinking in the containers as a wine, and it can be medicine and food in the meantime. That can explore more markets for products. Thirdly, we need to carry out diversified operations, integrated planting and breeding with tourism, and expand the industrial chain. Now we have most the primary products. We need to deepen the processing and to combine all the planting and also to cultivating and tourism, and together. Now we have some the pallets in Zhejiang, and it's for the 1 hectare mountain with 10,000 renminbi back. That is very good mode. And fourthly, we carry out the mechanism and realize the sustainable development. And the short-term economic benefit is considerable, which can really bring the morale to high for the farmers. But we still need to give a further research on the scientific and technical support, and to provide for those all the optimizations for the soil, for the forests, and for the medicine, this interaction mechanism. And thanks for your attention. And thank you. And Dr. Tsai, and based on the non-timber forest based economy, and provides us a very good case, very good cases from those lucid water green mountains to available assets conversions. Now we're gonna have Dr. Xie Jinzhong from the collaborative the Innovation and the International Cooperation Center Institute of Subtropical Forestry from Chinese Academy of Forestry, and the director of the Bamboo, the collaborative, innovative, and international cooperation centers. And also Professor Xie is the fellow from Jusan and the academic commissions, and achieved 2022. And for the providers from the NFGA, and 2020 of the China State Institute of Forestries. His topic for today: applications of bamboo biomass for economical cultivation of edible fungi in bamboo forests. I would like to take from 5 areas to talk about how to use the bamboo. Traditionally, we only have some physical utilizations, like some board or floor or some household products. And we also have some chemical utilizations, like for some pulp or carbon or fiber, etc. So today I would like to introduce a new utilization. It's like bio-utilizations, and take the bamboo as the base material, use a macro to develop this fungi productions. And so that is actually with a very high protein contents. We want to use this bamboo as the base matter to cultivate the edible fungus, because we can have every 2 years to harvest this. So first of all, I would like to give an introduction on this. The China is a very important bamboo producing country. We have over 100 million more for this forestry, bamboo forestry, over 2 million hectares first. And we can produce this bamboo processing waste exceeded 5 million tons, which can be used for the cultivation of the edible fungi. Second is for the under the forestry, we can have a very good management on this structure for this bamboo forestry. We every year, every 2 years, to develop this bamboo shoots. We have the different kind of this the like for the different kind like moso bamboo, and also for the bamboo shoots, early bamboo shoots. I think second is we have to or bundle the bamboos. Thirdly, we have a good lighting for the in the forestry, and that is really fit for those edible fungus under this forestry. And we have the very little the gap for the temperatures. And fifthly, we can also improve the utilization rate of land and the comprehensive economic benefits of the bamboo forestry. So we have the improved the land utilization and to provide the contribution for the food safety for the country. And for the post-harvest residues of the edible fungus are suitable for the growth of the bamboo forests. The forest land has a strong self-fertilizing ability and has the characteristic for the circular economy. And 7 is provide the employment opportunities for rural left behind personnel with significant social benefits. For the per mu, used 35 to 45 people, which really fit the women or elderly people to work on that. And also we have some the processing for those waste of this forest bamboo forest or bamboo forest processing industry. We have lots of the waste the bamboo forest and use this like mechanic the crunching, and we can have this the scrap for those bamboos as or further the development. And also we have some different kind of the fungus for the bamboo the scrams. We have the 97% bamboo chips and fermented for 50 to 60 days. And also for the big ball mushroom, which is fermented for 20 to 30 days. For the Arikison and blending, and which is like 30 days fermented. And also the mushrooms is like 50 to 95 bamboo chips fermented for 15 days. For all these years operations, we found some kind of the fungus really suit in this bamboo forestry. It's like for those like different kind of the mushrooms and a big ball the mushrooms. And we have the 2 harvest season in springtime and in the autumn. On the left, you see that is for on the left is in harvest in springtime. So I would like to give you some model 3 in Word. And first of all, for the like the Yalfora the Indacita, also known as bamboo fungus, and the bamboo ginseng, is the cryptographic fungus and parasitic on the roots of the dead bamboo, shaped strip, and with the 28 degrees, and with a very high demand on the humidity, and also need the humidity to the air is 85 to 90%. Lighting need 30%, and also soil is with the pH with acid 4.6 to 5. So we made some innovation on this preparation with 80 to 85 degrees Celsius and the degrees to kill the bacteria. And that is very easy to suit all the farmers can do that. When also we have the different kind of the chips, the bamboo chips. We have used the machine to make this the bamboo chips with the fermentations and for some supplements for the fermentation with 50 days for fermentations. And then we choose the grassland, the bamboo forest with convenient transportation, and with have the densities is 900 to 1,000 per mu. And also for this Cinocalamus and then latiflorus, which need to 50 to 60 pound per mu. So we have this caricatures is like each square meters, and to make this breed 2 to 2.5 bags, which about 0.5 kilo to 0.6 kilo. So for the planting, we made some innovation too. We to ditch the gap with a 15 centimeters deep and 30 to 40 centimeters wide. This is traditional planting. But recently we have the two ways. Use the non-woven bag with the diameters of like 30 centimeters and to plant. We used the fungus in the shade to make this the planting cultivation days in advance, like before. The planting term is like 30 to 45 days. And for per mu, we can put like 600 bags. And for management in this, the planting, the soil moisture and the normal weather after sowing. And we need 2.5 to 3 months to produce this fungus eventually formed. That is about like end of May, which is can make us to make sure we have a stable production, because in May in China, most of areas for those the raining season. So that is really can safeguard or can provide a stable production. For the harvest and the drying processing, which is in middle of the June to beginning of the September, that is grow very fast. They're growing very fast. So we need to collection in time. This is some pictures on site. After this debag, we got this planning in the bag, with the bag.
And then the sprouting rate is first is 70% and then 50% or 30%. So actually we use the non-woven textile bag and also made a comparison with the traditional model, and the quality wise actually the ecological cultivated products are greatly improved in many aspects, and the economic benefit could realize about 20,000 RMB per move. And these are the comparisons of the final ultimate benefits by different methods. And this is one of the famous mushroom in the world, and it is fresh in taste and very popular among the consumers, and it requires less for environment. Actually, it can be grown everywhere, and the nutrient requirement mainly include the say fibers and lignin, and but the for the moisture content, it requires higher, and at 70 to 75% also, and the growth temperature is between 22 and 24 degrees Celsius. And so actually the two types can be planted in different seasons in a year, and they can make a very perfect match. And the pH value is between 4.5 to 9, and the pH value is between 5 to 7. So actually the cultivation substrate is similar to say the zhusun, and usually in terms of fermentation time, and it is shorter, and 100% of the bamboo chip can be fermented for four weeks, and the planting time, the sowing time is the end of August and early September until the third quarter of January next year. And I will not repeat on the similar factors. So here we need to water them 1 to 2 times a day, and otherwise the quality will be compromised, and it can be refrigerated at 0 to 2 degrees Celsius, and also we can dry them, but before drying we need to cut them in half, and in 4 to 5 hours we could dry them efficiently. The economic benefit is higher, and because the cost is less than 9,000, but still the return can be 20,000 RMB. So this is another species. It is named as the toadstool, and but it has some difficulties in cultivation. That is to say, and the suitable temperature 10 to 20 degrees Celsius is only a short period of a year, and also we need to use 40% of the wheat and 8% earth and 52% of chip. So actually in the first quarter of October, and we could place the nutrient bags in the bamboo forest, and also we need to water them in the third quarter of January. So this is the environment, and so it needs to be shade up in the bamboo forest, and also the nutrient bags are needed. So our yield can be 25 pieces per square meters, and the single weight is 60 to 105 grams, and the total output can be 350 kilograms, and then the benefit, or say, is about 30,000 RMB. And finally, I would like to tell you something about the just like the configuration of different cultivation models. And model 1 is this combination in the first line, and the second model is the combination in the second line. And also we could adopt the say 2 seasons in a year model. And so we could divide 1 year into 2 production seasons and to realize the economic benefit. So this is our configuration. So here on this page, you can read my contact information. So this is my presentation, and you could contact me after the meeting. Thank you, Mr. Xie, for the very informative presentation. And he introduced the practice of planting fungi for the food purpose in the understory environment. And so actually we have made the bamboo forest a carbon sink into a treasury. And the next speaker is Yang Yaojun, the professor of Leshan Normal University. And he is the counselor of the Chinese Society of Forest. Currently, she is the director of the production lab. She has published 87 doctors, including 3 ESC papers. She led her team in molecule material, soil remediation. They have accumulated experiences, and today she is going to present the study and application of rhizosphere growth promotion system of bamboo fiber and its symbolic bacteria. Thank you, moderator. Ladies and gentlemen, good morning. My topic today is the rhizosphere growth promotion system of bamboo fiber, and it's a symbiotic bacteria. I will show you some pictures so you can see the earthworms underground. You may not believe there are so many earthworms in the bamboo forest soil.
grams. So we have the scientific phenomena is we have bamboo fiber plus the symbiotic bacteria. During this amount of the soil, there's this amount of the earthworms with a different kind of soil and altitude. And we have the presumption is the system promotes the mass reproduction of the earthworm. And actually, earthworm is the Earth's coexisting worms. So we say this kind of the system can improve the soil. And here's the question for the rhizosphere and the macro ecosystem is seriously out of the balance. And considering for this, the soil's nutrition, actually for the second nutrition level is being destroyed. So we're thinking of the build a soil on the rhizosphere and life and community use the first level to develop the second level, and the second level supports the development of the first level and the higher. So which is for the earthworms growth in the soil, and barren mountains can be improved. How can we build this, the structure, the system, which is like the rhizosphere's growth promotion system. One is for the water, the other is for the soil. So first of all, we invented the polymer water absorbing bamboo fiber. This we talk about. We talked about the Professor Xie and Chen. We use the scanning electron microscope to find, and also use the TEM to find this the diameters of this the pole, and then we screening for those the highly efficient the macro bio system for degradation of the bamboo wood fiber was found in this research, which constructed this the system. So we use this promotion system of bamboo fiber, and it's the symbiotic bacteria and the earthworms. This is like 4 dimensions. Then for under this the system, we have for the water absorbing bamboo fiber, symbiotic bacteria, seeds, and earthworm. And for this output for this earthworm, the soil improvement, and that for the for this system, and we get the profits is earthworm, because the earthworm is a very highly demand products, and also is for the herbs, the materials. And after a year, we see the change of the soil microsquatters. You see on the 2 sides there the bamboo forest. For the structures is really changed, and we also put this soil organic matters is doubled actually. And also for the earth, the macro organism is also improved. And for the number of the weight of the earthworm increased by 10 times. So it's a products. So after making soil improved, and then the earthworm's production also improved. And then we have the earth, the worms growing in this under this the economy, because for the bamboo forest is dark and down. Applying this system can overcome the problem of the water shortage and promote the earthworm to improve the soil. The applications can we make this system to promote this system under the bamboo forests and build this system? And for the number of the earthworm increased hugely. That is really good for the reproduction of the earthworms. We have some early bamboo shoots have the analysis, also called the phlostasis and paracox, the early bamboo shoots. And for the quality of these early bamboo shoots, really show the differences. You see the table show the changing quality of these early bamboo shoots. And the genes, there's in total is 6,563. Some up the gene up to 3,883. Among those, for those the fruit glues, it shows the significantly different and also changing for the sandy land. You see the during the real-time monitoring, we see the number is different. And in rural Gai County, for those sanitizations, they're changing. You see the fruits for this citrus is actually show the really differences. For the iron 36, as example, we see the genes is really changed. And for those in this research, and for those fold change, and really for this the differentiation for this the genes. And also we made some research on the pomegranate. You see, for the appearance, first of all, show the change. On the right, you see for that is for the control groups. And that is really show the roots is the activity increased. And so we call this the beautiful pomegranate. You see, for the color is very even for this pomegranate. And that is, you cannot really make it happen in an artificial way. The fourth is a technical model of the resin-fair growth and promotion. For all scenario is input and output. We input the water-absorbing bamboo fiber and symbiotic bacteria seeds, earthworms, and then we made the out production on earthworm soil improvement. Make the earthworm being reproduced hugely, and that we increase the organic matters for the soil, and also improve the value and volume for the earthworms. Through these earthworms can convert bamboo into medicine and meat, provide a feasible way for rural revitalization. And that is saving lots of the labors. And that is for your consideration. Through the earthworm to improve the soil, make soil fertilized, and also increase the organic matters, save the labors, and make more profit for per hectare, which can reach to 15,000 renminbi per hectare. So I will talk about this, highlights these three innovations. One is obtaining the super absorbent bamboo fiber and its symbiotic bacteria for the first time. Second is construct the Rattan sphere and earthworm growth promotion. And that's really solved the pain point. First of all, reduce the cost of the soil improvement, make a breakthrough for those the insufficient water for the earthworm growth, and also provide a feasible basis for bamboo forest and increase the efficiency and green for the society. So this project actually, we reached the two achievements for those the bamboo fiber. We have the provincial level, city levels leadership visit us and to see this project. So that's my presentation. Thank you. Thanks, Mr. Yang. So that is for our new innovation under this non-timber forest-based economy.
Please share your screen first. I'm sorry, Professor Lee, I think you are muted. Can you see my screen? Thank you very much, moderator. On behalf of my team, I would like to present the research progress on nutrition of preferred bamboo for giant pandas. Actually, giant panda is closely related to bamboo, but in the relevant research, we have done insufficient works. And also our research, even if exist, are not systematic. And next in my presentation, I will present the basic situation in this field. Nutrition is the cornerstone of life activities. bamboo accounts for more than 99% of giant panda recipes. The artificially bred giant panda consumes 90% of bamboo-related products. In our research base, bamboo accounted for 90%. Currently, 12 genera and more than 60 breeds are included in the edible bamboo species for giant panda. And I would like to share with you the relevant information in energy, crude protein, and amino acid, ether, extract, carbohydrate, mineral and vitamin, active substances, and anti-nutritional factor. And finally, I would like to talk about our current research in our base. And we hope you could join us in the relevant research. In terms of energy, the existing researches show that the origin species, parts, and the season do not influence the total energy of bamboo. The captive giant panda shows some differences in the apparent digestibility of energy when eating different parts of bamboo. Throughout the whole year, actually, the giant panda in different seasons would select different parts of bamboo. For example, in spring, the captive giant panda usually eat the the leaves. But after early spring, they would eat calm, and then they eat bamboo shoots. So different parts of bamboos are consumed by giant panda in different seasons. So I would say that digestibility is highest in calm and then leaf and shoot. So actually the structure is different as we have expected, but actually it is not. So the relationship between giant panda and bamboo are explored by different research institutions, including CAS. And the total energy input of white giant panda is 100 to 138, and the digestible energy is about 15.3 to 23. That is 12 to 23%. But the captive giant panda, and their energy consumption is lower than the white ones. So here we can see the total energy intake is 50.9 to 60.3, of which the a fine feed could provide 6 to 11 energy. And actually our previous researches are extensive. So in the future, we need to focus on the intensive research. As for the protein research, we usually believe the researchers in the giant panda believed that bamboo is a kind of a high fiber but low protein feed. But according to our analysis, the reality is different. For example, the 2 to 31% of crude protein can be found in different types of bamboo, and the bamboo shoot have 30% of crude protein, and leaves have 10 to 15% of protein, and culm have a lower share of protein. The crude protein and amino acid composition is listed in the table. So we can see the relevance of ingestion and food and feed intake. The energy, more than 50% of the energy of giant panda are from protein, and 39% from carbohydrate, and 13% from fat. Another issue in the face of the giant panda feeding is that the captive panda breeding base provided simple feed, sometimes due to the resource scarcity, we provided the only low protein bamboo to them. But in this century, we provided them with bamboo shoots. The problem after being fed with bamboo shoots will face the issue of high protein intake. So in this chart, we could see the intake should be 0.8 to 1.2 gram per 100 kilo. But the captive giant panda being fed with bamboo shoot will intake 4 to 5.7 gram per 100 per kilo. Bamboo shoot is good for human, but for giant panda, it is bad. According to our research, the high protein content could result in the kidney function changes. So we need to restructure the menu of a giant panda, and we hope we could provide them with a healthier menu. So in this chart, you could see the risks in damaging the giant panda's kidney because of the hazardous elements increases in their body. So our study explores the amino acid content in bamboo shoot, leaf, and culm. So actually, the lowest amino content in the three parts are similar, but the bamboo leaves and culm are differentiated in the amino acid ratio, and also the amino acid structures in different growth periods are different. As the bamboo grows older, the amino acid content decreases. Another research finds that the amino content changes as the altitude changes. So at 2,600 to 3,100 meters, and the amino acid content increases significantly. The research is to breed and feed the giant panda. So actually, based on the amino acid contents in the giant panda's muscle and milk, we could see the maximum value and the minimum value in different parts. So in the breeding process, we need to work out a scientific menu in order to enhance the giant panda's health.
For this part, as we talk about for the bamboos, the ether and extract for those the cultivated, captured the giant pandas, we need to beef up some the nutritions. For this the crude fat, because for the wild the giant panda, the 90% they will get the food from the wild the areas, which is that is their the habits and their eating habits. So for all the captured, when we raise the giant panda, we need to consider it based on the bamboos, their nutritions, and to provide the supplement for their feeds. And we need to be aware if the pandas take extra for the fat that which is well dangerous for them. And also speaking of the carbohydrates, that is like a nitrogen-free extras, which is total sugars and the mono and the scattering the resist and part of them being absorbed. For total sugars in bamboo is about 20%. And for the fiber actually is as high as 70%. And for those, the bamboo rods actually, that is actually the fiber contents is increasing. Why we want them eating the fiber contents higher or lower? And we need to give more deeper explore for that. I will welcome all the experts to visit our base and to have some research on the feeds of the giant panda. And also the different part of the crude fat is different. We have the research to show for the feeding intensity of the giant panda on bamboo is actually decreased with the increasing of lignin and the silicon contents in bamboo. And also we see some outside the overseas research from January to April, the proportion of the starch and also the hemicellulose in the bamboo stems increased, and which is reached a peak in April. That's why I just mentioned when the proportion of the fiber was the lowest and the proportion of the bamboo stems was the largest. And also for the existing mineral research mainly include K and the Ca and Na and Mg, and also the Cm and also Fe and Zinc, and that is the elements. So the existing research showed species, seasons, and parts and the growth cycle all affected the mineral concentration of bamboo. Among those, for the leaves is larger than bamboo shoots and then larger than the stems. And also is different impact. And also is related the contents of the heavy metal. And in our base, we have the research, the heavy metal, such as the suburb area or two sides around the road, the highway. For the heavy metals actually is exceed the standard. For some high mountains or some remote area, and that the heavy metals contents is actively low, relatively low. And that because and in futures, how can we control when we captured the giant pine resin? When we picked the bamboos, we are trying to as far as we can from the suburb or sides of the roads. And also for the mineral and the vitamin and in the bamboo, in the leaves. For example, in the leaves, for the calcium to P, and which is 6 to 7.7 to 1. And also for bamboo shoots, the ratio is 1 to 6.6. And for the giant pinus blood, we can see the calcium to P nearly 1.5 to 1. And that which means so different parts of the bamboo will show the different contents of the mineral and the vitamins. So when the giant pinus picked the bamboo shoots in the wild areas, they don't have the conditions have the supplement like we raising giant pine at our base. That is a very interesting atmosphere. And we also read some reports, especially for the wild giant the pandas. We see this, where actually is ongoing research in panda base. Next year, we may have some the more specific data. And also another research is on the active substances and anti-nutritional factors. And there is 34 exogenous bamboo me and RNA changed with the increase of lactation days of giant pine, which means for the giant pine, when decrease of the 3 days and may be related to the fasting of the giant pines. And for the 3D postpartum indicated that a giant panda can obtain the exogenous and the mRNAs from the food. And that is also for those indicating the exome loaded and exogenous bamboo and RNAs may promote the growth of development of giant panda cubs. And also for the hydrolyzed, metabolized with the small, the instituted from the equal, which exerts the function of the estrogen. The flavonoid content was affected by the bamboo path, variety and altitude and season. And the contents of the flavonoids in bamboo is proportional to the levels and reproductive hormones in the urine of giant pine. And also we have some flavonoids in the bamboo interact with the fecal microorganism of the giant pines. We also found the alkaloids and the nitrogen and derived secondary metabolite, and nitrogen containing a toxoid, while the tannins and for the phenolic and for the compounds, which are the digestibility reduced the factors. And also we have the giant pines have the high expression levels of the cyanide and detoxination related genes, and absorbed more than 65% of cyanide in food, of which about like 80% are the metabolized of the less toxic this cyanide. And then last year I will talk about our current work. And we have the panda base, and they have this germplasm resources of the bamboo eaten by the giant pandas. And we find some of the very good species, and take this the base, build this database for the nutritional contents for the bamboo eaten by giant pandas. So experts, you're very welcome to our base, and you have a deep research. We would like to hear your frontier research results and bring that to our daily work. Thank you. Thanks, Mr. Lee, for last centuries and for develop on this giant pandas. But with the bamboo resources decreased, and then this actually is a directions for future R&D. So for the 21st or the keynote speech meeting, we're gonna go to the base to visit and to study. Thank you for your presentation. So that is for my presentation. I will try to press to 10 minutes to finish. Okay. So So now we're hungry, and then we're just, for my last presentation. And I would like to talk about the research and demonstrations of key technology for cultural tourism and the recreations. And first of all, is the background. So the background is actually as we want to lay with the rich resources and lay the foundation for the future cultural tourism and recreation in the bamboo forests, which include we have the traffic calculations and the research. And second is for the rapid development of bamboo forest recreation provides a guarantee for the development of bamboo forest cultural tourism and recreations. So right now we see there's for the forest, the recreation tourism became a unified concept. And for us, we're trying to thirdly, for those President Xi talk about the lucid water and lush mountain will be the invaluable assets, and this guidance concept, and also we based on this concept, and to reach or practicing, and then we have some the natural concept for this greater the healthcare this concept, which also include or the aging population, and for the 3 years pandemic, the COVID pandemic, that really make us the pressure on our shoulders, like or the PCR, the testing, etc., etc., and that really bring us to think how to learn from the outside, and to learn this immune the therapies, and to build our health bodies. How can we and bring this and to go to those results forests, and to have a rest in these forests. And then we have this resources, and then how can we develop our industry? We have this forestry and recreation tourism. How can we combine this sports or holidays with all this the background?
So our idea behind the research is to build a culture tourism in bamboo forest, the theoretical system. Besides that, in order to solidify the theoretical foundation, we need to enrich the bamboo forest resources by developing new varieties. And as the previous speaker said, we need to form a recreation-oriented space technology. So we need to combine tourism with the bamboo forest, plants and animals in it, so that we could create a recreational and wellness environment. And also we need to expand or say develop the innovative products. So bamboo can be used to produce such culture tourism products. And so we need to promote the high quality transformation of research achievements into commercial use, so that we could strengthen our health and improve the economy. So our ultimate goal is to combine the recreation wellness and the bamboo forest management. And we need to conduct some comprehensive and systematic researches. So through building the recreational tourism system, we finally form a quality and integrated development of the whole industrial chain. So we have hosted different scientific research projects. In theory, we identify the concept of the cultural tourism and the theoretic system, including the recreation, sports, leisure, resort, amusement, and the sports, etc. And the multiple management models can be considered in the process. And the second highlight is we need to select the housekeeping function of bamboo forests, so that in different regions we could choose the best species for cultivation. In this way, we could combine organically the bamboo resources and the human health, so that we could further improve the relationship between bamboo culture and human, and also we build a recreational space structure index system, so that we could clearly identify the relationships between different factors. So the visual and the audio functions, and finally the health can be improved to resist aging, resist diseases, so that we could find a solution to meet all these requirements. We systematically developed the culture tourism products, and finally we could realize a psychological and physical development towards health, and so that the bamboo industry could be improved to serve the people's needs. And the fifth highlight is to create an integrated promotion system which enrich our previous design theory and practice platform, so that we could produce according to the demand. And a market-oriented quantitative production system can be established to lay the foundation of the industrial development. In bamboo forest design, we could compare our practice to the foreign practices. Our research achievements in China is advanced, and also in the foreign countries, it is advanced. We have obtained many patents with our standards, new varieties, and papers. So our peers, the academician Mr. Cao, Mr. Jiang, and Mr. Song, commented our works in this way, and the achievement reached the international advanced level technically, and the cultural tourism theory also reached a high level. So it is copied in Sichuan, Chongqing, Yunnan, and different regions and provinces, and their effects are obvious. And we hope our method could make the industry stronger, and we could combine the bamboo culture with other cultures, so that we could realize the economic benefits and provide a recreational space for everybody. And this is the composition of our team. And see, the research institutions, universities, and the industry are working together to improve the whole process. And we hope the communications and exchanges among colleagues will be carried out in, say, from time to time. Thank you very much. This is my presentation. Thank you very much for the participation. Thank you.